Shift left to identify and remediate vulnerabilities in code and infrastructure before they reach production. Software development and continuous deployment are rapidly evolving and changing daily. The most effective and least expensive way to remediate a vulnerability is to prevent it from ever being introduced into a production environment. This is the core principle of DevSecOps, a cultural and technical methodology that shifts security left by integrating security practices, tools, and responsibilities directly into the DevOps pipeline. 14. Traditionally, security has been an afterthought, a final gate that code must pass through before deployment. This model creates friction, slows down development cycles, and makes remediation far more costly and complex. When a vulnerability is discovered in production, it requires an emergency patch, a full regression testing cycle, and a new deployment, disrupting roadmaps and frustrating developers. By embedding security into every phase of the software development lifecycle, SDLC from coding and building to testing and deployment, organizations can identify and fix vulnerabilities at their source. This proactive approach not only strengthens the security posture of applications and infrastructure, but also fosters a culture of shared responsibility for security, breaking down the traditional silos between development, security, and operations teams. Shifting left. Shifting left is the central tenet of DevSecOps. It refers to moving security testing and validation to the earliest possible points in the development pipeline. Instead of security being a final, pre-production check on the right side of a linear SDLC diagram, it is integrated throughout the process, moving it to the left. This ensures that security is a continuous concern, not a one-time event. Infrastructure as code IX scanning. Modern cloud environments are largely defined by code. Infrastructure as code IX tools like Azure Resource Manager, ARM templates, Bicep, and Terraform are used to declaratively define and deploy cloud resources. A critical DevSecOps practice is to scan these IX templates for security misconfigurations before they are used to provision infrastructure. 3. This prevents common security flaws, such as publicly exposed storage accounts or overly permissive network security groups, from ever being created in the cloud environment. Container image and software composition analysis (SCA). Applications today are increasingly built from a combination of proprietary code and open source components, and are often packaged as container images. 2 key scanning practices are essential here. Container image scanning. This involves analyzing container images within the SICT pipeline for known vulnerabilities in the base operating system and any installed software packages. 3. If a vulnerability is found, the build can be failed automatically, preventing the insecure image from being pushed to a registry or deployed. Software composition analysis (SCA). This practice focuses on identifying the open source libraries and dependencies used in an application and scanning them for known vulnerabilities. Given that open source components can make up a significant portion of a modern application's codebase, SCA is critical for managing supply chain risk. Providing code to cloud context. A major challenge in DevSecOps is bridging the gap between a developer's view of the code and the security team's view of the production environment. Effective DevSecOps provides developers with code-to-cloud context, helping them understand the security implications of their code within the target cloud environment. 3. This includes providing clear, actionable remediation guidance directly within their native tools, for example, their IDE or pull request interface, rather than sending them a separate report from a security tool they don't use. Microsoft implementation. Microsoft provides a comprehensive set of tools integrated into the Defender for Cloud platform to enable a robust DevSecOps program across multi-cloud and multi-pipeline environments. Microsoft Defender for Cloud DevOps Security. DevOps Security is a core component of the paid Microsoft Defender CSPM plan and is designed to provide unified security management from code to cloud. For it offers centralized visibility and control over the security posture of DevOps environments, including native integrations with Azure DevOps, GitHub, and GitLab. 3. Key capabilities of Defender for Cloud's DevOps security solution include unified visibility. It provides a single dashboard within Defender for Cloud to view the security posture of all connected code repositories, SICT pipelines, and development environments. This allows security teams to manage and enforce security policies consistently, regardless of where development is happening. 4. IAC and container image scanning. Defender for Cloud integrates directly into SICT pipelines to perform automated scanning. It can scan IAC templates ARM, Bicep, Terraform, CloudFormation, and container images for vulnerabilities and misconfigurations. This can be configured to fail the build if high-severity issues are found, effectively blocking insecure code from being deployed. 3. Secret scanning. The platform can scan code repositories for exposed secrets, such as API keys, connection strings, and private keys, which are a common source of breaches if accidentally committed to code. Actionable remediation guidance in developer workflows. One of the most powerful features is the ability to surface security findings directly within the developer's native workflow. For example, when a developer opens a pull request in Azure DevOps or GitHub, Defender for Cloud can post annotations directly in the PR, highlighting the identified vulnerability and providing clear code-level remediation guidance. 19. This tight feedback loop empowers developers to fix security issues quickly and efficiently without having to leave their familiar tools. Code to cloud context. By correlating findings from the development pipeline with the runtime environment, Defender for Cloud can help prioritize vulnerabilities. For example, it can highlight a vulnerability in a container image that is currently running in a production environment with public internet exposure, providing the full context needed to understand the real-world risk. 3. By implementing these capabilities, organizations can move from a high-friction, reactive security model to a seamless, proactive DevSecOps culture. This not only improves security, but also accelerates development by reducing the time and cost associated with fixing vulnerabilities late in the lifecycle. The goal is to make security an invisible and invaluable partner in the development process, fostering a culture of shared ownership and continuous improvement. 9.